Hello there, Mr. Sutton with a lesson on central angles and arcs. Specifically, we're going to use central angle measures to find arc measures and vice versa. We're going to begin by going over some important definitions. A central angle is an angle whose vertex is the center of the circle. So, for example, angle A here is a central angle. Now, this angle creates some what are called arcs. An arc is a piece of the circle, and we measure these in degrees, just like angles. So, for example, here, angle A is creating arc BC. Of course, you might be wondering, are we talking about the BC when you go counterclockwise, or the BC when you go clockwise? So there's actually two kinds of arcs. The smaller arc, the minor arc, is the arc created when the central angle is less than 180 degrees. And we name these using only 2 points. So, for example, if we're just talking about this smaller arc here, we would call this minor arc BC. Note the little arc symbol that we do above the letters. Now, if you want to talk about the larger of the two arcs, the bigger arc, that's called a major arc. That's on the part of the circle that's greater than 180 degrees. And we use 3 letters to distinguish this from the minor arcs. So, for example, here we could call this major arc here arc BDC. Or we could have called it arc CDB. But you have to have that third letter in there, that third point, so that people follow which way you're going to name that arc. Let's talk a little bit now about the relationship between arcs and angles. So let's say we want to find the measure. This is the measure of arc GF. And since this is using only 2 letters, that's giving us this minor arc right here. So as luck would have it, the measure of a minor arc is just the same as the measure of its central angle. So measure of arc GF is also going to be 97 degrees. Of the 360 degrees on the outside of a circle, we're just using up 97 of them here. It also works in reverse. If I have a minor arc and I want to find the measure of the central angle that goes with that, again, they are just one and the same. So we could say measure of angle K in here is also 53 degrees for this diagram. Here's a slightly different problem. Same circle, but let's say that given this central angle of 97 degrees, I want to find this time the measure of arc GHF. So that's GHF, the major arc. What's the relationship between a minor arc and a major arc? Well, the whole thing adds up to 360 degrees, so the major arc is just going to be 360 minus the minor arc. We know the minor arc here is going to be 97 degrees, so 360 minus 97 degrees is going to come out to 263. All right, here's another problem, almost the same. Pause the video and see if you can figure out the measure of arc JML. You think you have it? So we already have minor arc here of 53 degrees. 360 minus 53, that's going to give us 307 degrees for that major arc. Here's another example for you to try. Pause the video and see if you can figure out the measures of these 3 arcs here. All right, let's see how we did. So trying to find the measure of minor arc RS, that's this arc right here. It's going to be the same as the central angle for that arc, so that's also going to be 110 degrees. We're just warming up though. How about major arc RTS? Well, this is basically every part of the circle that this 110 degrees didn't cover. So 360 minus 110 is going to give us a major arc of 250 degrees. And this last one is kind of tricky. RST. Now you might be saying, well, hold on a sec. I don't know how much this TS arc is here. I mean, if I did, maybe I could add that in 110 and get this other arc. The key here is to realize what exactly is forming this major arc. We've got a diameter going through the circle here, and we know it's a diameter because it's going through the center. A diameter, as it turns out, cuts a circle into 2 180-degree semicircles. So if you've got a diameter, both arcs formed by it are going to be 180 degrees. We're going to do another example in a moment, but first let's officially define a very useful property called the arc addition postulate. This basically says we can add arcs together or subtract them. We've already been doing that intuitively, but now we know that we're officially allowed to do it. All right, let's go ahead and find these different arcs here. Now, just as a little tip, I recommend when you pause the video and try this, that you try to find measure of angle AM first. That'll make all the rest of these much easier. All right, let's see if you took my advice. So to find AM, we know all of these other arcs except for AM. We know all of these together have to add up to 360. So 360 minus whatever all these other arcs add up to, that would give us AM. So we've got 360 minus, let's see, 60 and 20 is 80, plus 110 is 190, plus another 90 is 280. So that's a grand total of 80 degrees for AM right here. Next, to find minor arc MC, we just have to take 80, 60, and 20 and add them together, and that's going to come out to 160 degrees. How about measure of arc AD? So that's this arc over here. That's just going to be AM, which is 80 plus 90. So that's going to be 170 degrees. And finally, AC, well, that's even easier. That's just 60 and 20 adds up to 80. For our final problem, suppose we're given a circle with these three central angles here. Pause the video and see if you can figure out the value of x. All right, let's see how it went. Now, if we knew these other two central angles, we could add all five of these together and set it equal to 360. But we don't know these other angles. We could probably find them, but there's an easier way. Notice that 8x minus 3 and 135x are both making up this entire semicircle here that this diameter is creating. So we can just say 135 plus 8x minus 3 equals 180 degrees. So that's going to be 132 plus 8x equals 180. Subtracting, that's going to be 48. 8 divided into 48 gives us an x value of 6. This concludes our lesson on central angles and arcs. We'll be extending this information in the next lesson to figure out sector areas and arc lengths. Until then, this is Mr. Sutton signing off.